This is the last topic for exam 2 material. After this, we may do some more example for percentage, but we need the example today for you to do homework 10. When we try to find the probability, what does probability tell us? And when do you hear about probability? What are some of the situations you will use probability? What is probability? So if you have a bunch of marble with different color, how likely you're going to draw certain color? So that's one scenario where elementary level appropriate. What about daily life? Where will you hear about probability? How about weather? What's the chance it's going to rain tomorrow? They're using probability to predict weather. Anything else? The most common example people use is what? The biggest things for probability is gambling. When you buy lottery tickets, they will say how likely you're going to win the first prize, second prize, or the scratch off, like how likely you're going to win $2, $5. Prediction of weather, gambling, how likely people are going to vote, how likely they're going to vote Democrat or Republican. A lot of them, they will start collecting data first. Using statistic, and then they will make the prediction. In exam 3, we're going to cover some of the statistic topics kind of related to the probability parts. In general, probability explains how likely something is going to happen in the future. For example, if they flip a coin, how likely you're going to land in the head or tail. If you do it many times, like a million times, it should settle to about 50% head and 50% tail. In theory, they're going to be 50% head, 50% tail. But in the reality way, if you actually do the experiment, it may not be exactly 50-50. One of the things you need to know, important, that is the answer for any kind of probability has to be between, if it's percentage, it has to be between 0 to what? 100%. So if somebody tell you 125% chance is going to happen, that's not probability, it's something else, okay? It has to be within 100%. If they give you decimal number, which you can also use decimal number to represent probability, then it would be between 0 to what? What is 100% for decimal number? Yes. How about fractions? It's going to be between 0 to, what is the 100% for fractions? You say 0 to 1 for decimal, fraction would be 0 to, okay, let's think about half of this. So if I'm landing in half, then for percentage, it would be what? 50%. If for decimal, 0 to 1, half of them would be 0.5. For fraction, half would be 1/2. So the whole would be 1. I would expect you know this one, actually. I would think you will stuck on the decimal one, but if you are asking for probability and you find an answer and they're not between this number, your answer is going to be wrong, okay? It has to be between 0 to 1, any type of probability, or 0 to 100%. So earlier, we kind of talked about what do we use probability for. We can do weather predictions. We can talk about gambling or lottery, how likely you're going to win something. And later on, we are going to connect this with statistic, because in statistic, you're going to collect data. We're going to somehow organize the data and then analyze the data to make some analysis. And then using that, we're going to make predictions. And the prediction, a lot of time they're using some kind of statistic. So they can collect data with weather to predict how likely it's going to be a tornado coming, how likely it's going to rain. For voting, they found a sample and collect data from the voter and then predict how many percent of women is going to vote, how many percent of the men is going to vote, and how many of them are going to be Democrat, Republican, something like that. So The very basic type of probability, one type of them we can calculate is when the probability, when the outcome are equally likely. I have a hard time writing today, sorry. So the first type of probability we're going to show you is when the outcomes are equally likely. Then the formula we do this. This is the probability notation is P of something. Inside the parenthesis, you will describe the event. Could be different things, but we will write that out. So this is probability of an event is going to equal to the number of favorable outcome over number of total outcome. So this is a basic type of probability, and we're going to do a few of those. If we are rolling a dice, apparently they are trying to eliminate the gambling side of probability in public school. Some of the textbook may describe that as number cubes instead of dice. What kind of outcome can I have when I'm rolling a regular fair dice? The totally we can have how many outcomes? Think about how many sides of the dice do you have? 6, okay, totally you have 6 outcomes. What are the outcomes? I'm going to list them in a squiggly brackets. We can land at 1, 2, 3, 4, 5. Those are the possible outcomes, right? And later on, they may show you other type of dice. They may have more than 6 sides, but they will tell you that. So how many number are odd and how many number are even? 3 odd numbers and 3 even numbers, right? Those are the facts. And sometimes when people doing probability, they usually need to figure out the total outcome first. That part is not going to be between 0 to 1. Like here we have 6, right? So some of the question may just figure out the total outcome. So the number of the answer is not going to come out as between 0 to 1 or 0 to 100%. But those are not probability, okay? When we do probability, we may say, okay, A, I want you to find the probability, and they describe the event, right? Rolling a 6 for a fair dice. What would that be? Equal to the favorable outcome over total outcome. How many 6 do we have? Just 1 out of how many total outcome do we have? 6. 1 6 is a possible solution because it's 0 to 1, right? And they can do fraction, they can do decimal, they can do percentage, right? That would be an example. The second one, if I ask you the probability of rolling an even number, how many even number can I have? 3 out of total outcome is 6. And this particular fraction we can reduce by 3 on top and 3 at the bottom, right? So that's going to give me 1/2. So half of the time you're going to land on an even number, correct? Okay, questions? All right, so the next question is about playing cards, and the recent year people are not very good with playing cards, and you don't know where's in there. I guess you only play computer games nowadays. Let's list some of the facts before we go into some of the questions. If I have a deck of cards, how many cards are there? 52. Good job. Totally, we have 52 cards. What color are they? How many different color are the cards? 2 different color. What color are they? Black and red. Okay, how many black? How many red? If you have 2 color and total you have 52, what do you think? Divide by 2, that's going to be 26 black cards and 26 red cards. What are on the cards? Starting from Jack, that's kind of random. What else do you have? Jack and Queen, King. What else on there? Ace. Okay, so you have Ace, Jack, Queen, and King. What else are on the card? Let's not count the Joker. What else are the regular cards? Starting from what number? Do they have 1? So the 1 is the ace, okay? 2 until where? 9 or 10? 5, 6, 7, 8, 9. I heard. Do we have 10? Okay, if I have questions like this, I'm going to list this fact on the side, okay? So I'm not testing you how good you are, what's on the card, but to calculate the probability, all right? And then for each of those, they also have 4 different symbol or type of them. What are they? Vase, okay? I'm going to draw it. Hearts, okay? Okay, one more. My drawing is bad, sorry. Okay, those 4, right? So meaning A's have this 4, 2 have this 4, 3 have this 4, right? If I ask you to find the probability of pulling a card in random, and that would be a queen of hearts. You want to think about A, we are doing P of, I need a queen of hearts. How many favorable outcome? How many total outcome? How many cards do you have have queen on it and have a heart on it? What do we have? How many queen of heart do you have for the whole deck? Okay, thank you. And then totally, how many cards do we have? 52. Okay. Next, how about drawing just a queen? Probability of queen. I have a hard time even writing, sorry. So you want to think how many totally queen do we have for the whole deck? 4 cards out of totally we have how many cards? 52. We can reduce it to, both of them can be divided by, okay, 2. That will give me what? Okay, and then they can be reduced by 2 again. We get 1 out of 13, which kind of makes sense, right? You have 13 of those different type here. So 1 out of 13. And then C, how about drawing a black color cards? Probability of drawing a black cards. How many black cards do we have? 26 out of 52. That would be half, right? So we divide this by 26 divided by 26 equal to half of the deck would be black. Is it okay? So this is just basic. Favorable outcome out of total outcome. All right, the next one is not equally likely. So we're going to do some of those. If it's not equally likely, if I draw a circle, cut it in half, do the best you can, call this 1, cut another half, so this is a quarter, 2 here, and cut that 1 more half. I didn't do a super good job. This is 3 and 4. I'm going to just demonstrate to you, but at home you can try that, or if you have a paper clip with you, you can try that. So this is a spinner. I should draw a better circle, but like basically you put a paper clip there and you put a pen here and you flip it and see how likely it lands to certain one, okay? So that's the probability. But basically this is a circle, half, quarter it, and half of this. Probability of spinning and getting a 1, probability of getting a 2, probability of getting a 3, and probability of getting a 4. So this time is not equally likely. Obviously, it's more likely to land on what? 1, because it covers more surface area, right? We figure that out. We can figure out a fraction or percentage. Either way would be fine. Getting a 1 would be what? 50% or half of the chance, right? Half of the circle, right? So you can say half or 50%. Either way would be correct. Just cannot go over 100, right? Second one, getting a 2 will be a quarter of the circle, or how many percent? 25%. Can really see that? And getting a 3 is half of a quarter, which is what? 1/8 of a circle, which is how many percent? Half of 25 is 12.5%. Are we okay? So this is also 1/8 or 12.5%. And if you want to show more steps, it's okay. But I think we got that. How about probability of landing on an odd number? or probability of landing on an even number. Everything we do here is just in theory. If you do the actual experiments, may not have the same number unless you do it many, many, many times, like a million of times. Odd number, which one is odd number? 1 and 3. So I need to combine the probability of getting a 1 and then probability of getting a 3, right? For 1, we have 50% or 1/2. And for 3, we have 1/8 or 12.5%. Do you want to add the fraction or percentage? Percentage. Because if you add the fraction, you're going to need what? Common denominator, right? So it's going to be 50% plus 12.5%, right? Which will equal to 62.5%. Do we agree? All right. Can you go ahead and find me the even number? Similar way that we did the odd number. What did we get? 37.5%. Did you do the way I did here? Sorry, cannot see. So I'm combining the probability between getting a 2 and getting a 4. I combine the percentage. You can combine the fraction also, but need common denominator. Is there another way we can get to this number? I know this. Is that going to help? Yes, so they are complement of each other. They complement to 100% basically. So we can also use 100% subtracting the probability of getting an odd number, which is 100% subtracting 62.5% should also give you 37.5%. That would be the probability of getting an even number, right? Are we okay with that? Now we go to your drawing the marble or the bag. So also not equally likely. Another example, we can have a bag with different color of balls or marble. I can have blue, a blue, and a blue. And then we can have red and red. I want to find the probability of getting a red color ball if we draw a random color ball out. And the second one would be probability of drawing a blue one. I'm still going to need to figure out a favorable outcome out of the total outcome. What do you think? Drawing a red one? How many out of how many? 2 red one out of 5 total, right? The 5 part would be the 2 red one combined with the 3 blue one, right? So 2/5 is the probability of drawing a red one. How about blue? 3 blue one out of 5 total. 3/5. Are we okay with that? This is just the very basic one because this class is for elementary level, okay? If you middle school, they may say, what is the probability of first draw blue one and then the second is a red or something. So they can have combination and an all probability type of thing. So when you get to be certified, say you want to do, I don't know the certification because they keep changing it. My certification is kindergarten to 8th grade. So I don't know about now. Now it's EC through 6. Is that right? Okay. So if you do EC through 6, you pass both PPR and the subject matter. So they have a content exam and a professional development. If you pass that, then if you want to be certified, say I want to certify in bilingual, I want to certify in middle school math, or I want to certify in high school math, you don't have to take additional classes if you don't want to. You can just study the test and challenge the test. If you pass it, then you're certified to teach other subjects. So I have a student pass the elementary one and then come back and ask me, like, why didn't we cover those like N and all probability? I was like, because it's not elementary level. What are you doing? So she was trying to certify in middle school. So once you are certified, and then if you want to teach more subjects, say I want to certify in special ed or something, then you just need to study the test and pass it. Keep that in mind. Also, a lot of the school districts, if after you're teaching for them and you want to get a master degree or something, they may pay for it. But it would be related to the job type of degree, not just like a random degree. You may want to look into that also. And nowadays, I think when you do the internship, they pay you. A lot of the school district, not when I was doing it. When I was doing it, I paid for 18 hours and then I worked for them free. I was so well during that time. Now it's better because they need teacher and we're glad that you're interested to become a teacher. And the public school pay pretty good. The starting pay, some of them is like 60,000 or more. For our departments, a master degree instructor position, I think the starting salary is still like 48 or 50. You get paid more in public school, but it's a lot of work. It's hard work, okay? Just, it's a pretty good pay, I think. We're going to step away from the probability for a second because a lot of time you need to figure out the total combinations or the total outcome. This would be some of the scenario to figure out how the total outcomes are. And this total outcome is not going to equal to 0 to 100. We could have a question asking, so say I'm going to download 3 movies for the weekend. It's spring break, you're going to watch some movie. And this is still kind of dated because the original question is they're going to go rent 3 movies, which we don't have that anymore. Probably not. Maybe the web box still you can rent 3. So I'm going to download 3 and you're going to watch each of them just one time. How many different order can you watch them? We are looking at combination. We have 3 movies. I don't know what kind of movie. Can you find me a movie start with A, B, or C? Them A, B, and C. So we have basically 3 slots, right? I'm going to only watch each of them one time. The first movie, how many choices do I have at this point? 3 choices. I started with 3 choices after I watched one. On the second movie, how many choices do I have now? 2. And the last one? Just 1. I can change this question slightly. I think one of the exam questions I may say you have 3 different color of flower and you're going to plan it. How many different combination can you have? Basically, we are multiplying all of them together. So together, how many order can I have? 6 orders. And if I ask you to list them, you can say I can start with A and watch B and C, right? And then I can start with A and watch C and B, like that. And then I can start with B, right? If I start with B, I can have what? B, A, C, and B, C, A. And then if I start with C, C. So either way, you should have 6 different combinations. Are we okay with that? I have to do at least 2 more. Okay, one of the question will be if I start with phone number, how many phone number can you have if it start with, okay, 214, let's stop it here. 214, because my example is from Commerce, it's 903. Started with this, 214, 112. And then I have 4 more number to fill, right? So I want to know how many phone number can I make with that. You want to think about for each space, how many choices do you have? The choices of number will be between, you can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it, right? Can they repeat? Yes. Can repeat. Because last example you cannot, right? So meaning each space you have how many choices? 10 choices. Because it's 1 to 9 plus the 0, right? So you have 10 choices for each digit. So it's going to be 10 choices for each slot times 10 times 10 times 10. How many numbers is 10 to the 4, meaning 40, right? 1, 2, 3, 4. How many phone number can you make with this? 10,000 phone number. I think the homework question, you have 3 more space to fill. 1 more, because you need that for your homework. We have 5 minutes. How many outfits can we make? If we have 4 shirts, 2 pair of pants, and 2 pair of shoes. And your outfit is going to be shirts plus pants plus shoes. So they ask you how many outfits and they want you to list the order after that. First, how many outfits? How do we calculate that? Very similar to earlier. How many choices for shirts? 4 choices times 2 choices for pants and times 2 pair of shoes. Together we have 16 different outfits. If they ask you to list not just the total, then you're going to need to do a tree diagram, I would suggest. The tree diagram, we can say for shirts, we can have 1, 2, 3, 4 different shirts. And for pants, we can say A and B for 2 pair of pants. And for the shoes, I'm going to use the Roman numbers 1 and 2 like that. And I'm going to list them out as a tree diagram. I'm going to have 1, 2, 3, and 4 for shirts. The first shirt can pair with pants. How many pair of pants? 2 pair. So I'm going to bench out 2 times for each shirt. Is that okay? The pen can be pen A or pen B. Sometimes students like to assign them color. I am lazy for that. A and B. So each shirt can pair with pen A or pen B, right? And each shirt and pen combination can branch out to what? The 2 pair of shoes. So shoes, we have 1 and 2 like that. So first shirt can pair with pen 8 and the first pair of shoes, something like that. And then so each one will branch out 2, right? A little bit messy, but if they want you to list it out, it's kind of like that. And if you count, how many combinations do we have? The last branch, like 2, 4, 6, 8, 10, 12, 14, 16, right? It should also be, you got
16 outfits.
So I have a little bit more example, but all this should be able to help you to do the homework 10